So, I mean, Torres and I are very much on the same page because we both have the same event that we need to go to next week. So, like, we have been trying to get all of Unit 1 done this week. Rodriguez and Mr. Elam are both on the normal pace, so they'll finish teaching it by Tuesday, and then we'll all have study guide day on Wednesday, and then you take your test. So my class might be a little bit more ahead than your class. Today we just barely scratched the surface on the 12-13 lesson. The 12-13 lesson was combined because it's just about standard deviation. And really, we've been talking about standard deviation since the beginning. I made sure that we learned how to calculate it. When we learned how to calculate everything else, we did not need to learn how to do it by hand because there's no need. Like in the real world, you don't calculate things by hand. Computer, put your data in. So standard deviation, you do need to understand and what it tells you about a data set. So it's another measure of variability. What does variability tell us about a data set? Okay, so I'm glad you guys could tell me that very fast. I still need like everyone to be able to say that by the time I take the test. Like I still have kids that when they're called on and they're just asked what is standard deviation, tell me about a data set, they just like are blinked and they don't say anything. You need to be able to say that. If it's a measure of variability, like MAD, IQR, range, standard deviation, it tells me how spread out the data is. Obviously, they're all different a little bit, like they're calculated all different ways, but it's how spread out your data is. So if something is very spread out, would I expect the standard deviation to be high or low? The more spread out, the higher the standard deviation. What's the lowest standard deviation you could have? 0. Can't have a negative standard deviation. So the lowest you can have is 0, and that would be not spread out at all. That would be like all your data is the same number. I can't see my mouse, so forgive me. But say that you have a data set that looks something like this, and a question on the test is saying, what does this point being added do to the standard deviation? What does it do? Would it increase it, decrease it, or stay the same? Because I'm increasing what about the data? The how spread out it is. Me adding a point that's away from the rest of my data will make that data more spread out. And you can play around with numbers in your calculator too. But what would adding this do to the mean? Would it increase, decrease, or stay the same for the regions? Because I put it on the right of the data and to the right of the number line, do the numbers get bigger or smaller? Okay, good. That means that if I add the data points here, the mean will increase. What about, if I add it on this side instead? What will it do to the mean? It will decrease the mean if I do that. What would it do to the standard deviation?
So it decreases.
Standard deviation would increase, but I'm changing how spread out it is.
Oh.
Away from the center of the data to the left of the data. So standard deviation and mean are different. Mean tells me like a typical value of the data set. Standard deviation just tells me how spread out it is. So it can be true that one increases and the other would decrease with the same equation. Okay, so that hopefully gives you enough to be able to try your practice for 12 and 13. I made sure it was available. Sometimes Rodriguez will unpublish it again, so I might have to publish it for you to be able to work on. But, sorry, I did that. Just tell me if it's not there and I'll make sure you have access to it. Since you're all here, that's what I want you to work on first to get 80% or higher. And then after that, you need to turn in your foldable, your box plot foldable if you haven't yet. So this is first priority. And then your box plot foldable after. And answers. Right now we are doing lesson 12, number 4. So let me think about your number 4 on lesson 12, which. So again, you should only be speaking if you're answering my question. So the mean of the data set is 43.5, the MAD is 3.7, the mean of data set B is 12.8, the MAD is 4.1. Which one shows greater variability? So they just gave you mean, which is a measure of what? Center. Mean is a measure of center. So mean is center. And they also gave you MAD, which is a measure of what? Variability. Sorry, I have to stand back here because then I can't see my mouse. But when it says which data set shows greater variability, you should be comparing the MADs, which is greater for data set A or B. Okay, so that's going to be this one. B shows greater variability because the MAD is greater than the MAD for B. So even if you forgot that, you can kind of use the blanks to help you. It's the one with the greater MAD was data set B anyway. What differences would you expect to see when comparing the dot plots of the two data sets? Complete the following to explain. A's dot plot will have the most data centered around blank. So again, go back to center compared to variability. We're talking about data set A right now. Where should my data be centered for data set A? Around what? No. 3.7 is the math. What should the data be centered around? That's why mean is a measure of center, because that's where the data should be centered around. So what number should the data be centered around? 43.5. Guys, stop with the noises. All noises. Talking noises, sound effects, we don't need it. Yes. So A's dot plot will have most of the data centered around 43.5 because that's the mean. That makes sense. Mean is a measure of center. With the data on average blank units above or below blank. So that's where the MAD comes in. This is kind of like saying on average the data spread out by like 3.7. So that's where this comes in with on average 3.7 units above or below my mean. B's dot plot will have most of the data centered around what? What is B's measure of center? Good. So 12.8 there. With the data on average, blank units above or below, so their MAD was 4.1. So that means on average, it's going to be spread out by like 4.1 around the mean. Okay, so that's how you accurately fill in all the blanks. Let me make sure the key is right. Okay, it says one of them's wrong, but I think I'm right, so I'm going to see what it says. Shows greater variability because the MAD is greater. Oh, okay, so I made a mistake in my English. That should be A right here. Now it makes more sense. B shows greater variability because the MAD is greater than the MAD for A. Okay, now there's no error. Questions on this one? This question? Questions on others? from either 12 or 15 practice or regular practice, yes? Okay, I'll set that up. Did anyone else have any other questions? Yes. So let me get that going. If you have other questions, make sure you ask. Follow along. We're on lesson 13, number 4. We have what? Oh, okay. Just kidding. Maybe not number 4. The number 1, you mean? Okay. So 3 drivers competed in the same 15 drag races. The mean and standard deviation for the race times of each are given. We're going to answer which driver had the fastest typical race time. So you need to know what to compare. Would the mean or the standard deviation tell me a typical race time? The mean would. So the mean, average, they tell you typical values or what your data is clustered around. So we should be comparing the means, which are these numbers. Which driver would have the fastest race time? B is the fastest. A took the longest, right? So B is faster since they took the least amount of time. Which driver's time were the most variable? So which one is a measure of variability? Mean or standard deviation? Standard deviation. When we say most variable, that means higher standard deviation. Which of these numbers is higher? No. A, like compare decimals like money. That's like 5 cents. This is like 12 cents. This is like 19 cents. So whose is the highest? C. So now, which driver do you predict will win the next race? Let's see the context clues here so we can pick the right one according to them, because we could have different opinions, but like they have a certain one picked. So even though the driver's mean race time is between the other 2 race times, okay, so let's look at the means again right here. Whose mean is between the others? C, right? Like if you rank them, A is the slowest, C is the next slowest, B is the fastest. So they're putting basically driver C in this blank. And theirs shows more variability. That means sometimes they're slow, but sometimes they're fast. So according to this sentence, they predict that driver C will win because their mean is in the middle and they have the most variability. Questions on that? Okay. Any other questions? I think Ion, did you have a question?
Okay.
Something else?
I got the